Hello, grade 11. Let's start the presentation of organic chemistry, okay? Where the organic chemistry, a branch of chemistry that studied the compound of carbon and hydrogen, which known as hydrocarbon compounds, okay? And the organic compound also derived from living organisms. Hydrocarbon divided into subgroups where we have aliphatic hydrocarbons and aromatic hydrocarbons. Let's start with aliphatic hydrocarbons. Aliphatic hydrocarbons may be found in two shapes, may be open chain and known as a cyclic aliphatic hydrocarbon, or cyclic saturated chain, which known as cyclic saturated. Aliphatic open chain may be saturated or unsaturated, where the saturated aliphatic hydrocarbon characterized by presence of single bond linked the carbon atoms in a carbon chain. Example, alkanes. Alkanes compound, okay, like methane and ethane and propane, also contain single bond between carbon atoms, okay? While unsaturated aliphatic hydrocarbons may contain double bond or triple bond, where the double bond linked between carbon atoms, while triple bond linked between carbon atoms. Examples of hydrocarbon compounds that contain double bond: alkenes, while alkynes contain triple bond between carbon atoms. Okay, examples of alkenes: ethene or propene, while examples of alkynes like ethine or propyne. Let's start with the alkanes group. Okay, alkanes, they are saturated hydrocarbon. They have only single bond between their carbon atoms, and their general formula CnH2n plus 2. Okay. Look at the table in front of you. We have many examples of alkanes compound: methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane, the last one. By studying this table, we observe that all alkanes are characterized by general formula, chemical formula CnH2n plus 2, where each compound exceeds the previous one by methylene group, which is symbolized by CH2. Okay? Members of this group are ended with a suffix, as we see, A and E. Okay? Like methane, ethane, propane, butane, and so on. And this group of alkanes form homologous series. What's meant by homologous series? It's a group of compounds that having the same general chemical formula, and also they have the same chemical properties but graduated in their physical properties. Okay? Alkyl group or alkyl radical. The alkyl radical formed by removing one hydrogen atoms from alkanes. Okay? Alkyl radical considered an organic atomic group, okay, which doesn't found alone. They should be attached with another group or halogen. We note that alkyl radical derived from the corresponding alkane by removing one hydrogen, so its general formula or chemical general formula CmH2n plus 1. The name derived from the corresponding alkane by removing ANE by YL. Okay? Give example. Methane, by removing one hydrogen from methane, it changed into methyl. Do you note that? ANE suffix changed into YL. Okay? Ethane also lose one hydrogen and it change into ethyl radical. Okay? Propane lose one hydrogen and they change into propyl radical, and so on. Okay? Again, alkyl radical, organic atomic group which doesn't found alone, derived from corresponding alkane by removing one hydrogen, so its general formula CnH2n plus 1, and the name derived from the corresponding alkane by replacing ANE by YL. The nomenclature of alkane. Alkanes, or the most of organic compound, have two names, common name and name according to IUPAC system. Okay, what are the difference between them? The common name come from their sources in nature, while IUPAC system, okay, it's considered international union of pure and applied chemistry, and this system depend on the number of carbon atoms in the longest continuous carbon chain. So the name according to IUPAC system depend on the number of carbon atoms in the longest continuous chain. Okay. Let's start. Okay, wait a minute. The question, compare between the common name and the IUPAC name. The nomenclature of alkanes by IUPAC system may be summarized as follows. Number 1. The name of the hydrocarbon determined according to the longest continuous carbon chain, which may be linear, as in this example, or branched, as found in other example. Okay, so the longest continuous carbon chain may be linear, okay, or branched. The carbon atoms are given number in the longest chain. If the longest hydrocarbon chain free from any branches, okay, or side group, so the numbering of carbon atoms are given numbers from any side, left or right. But if the longest hydrocarbon chain attached to alkyl group, okay, or any other atoms, so the numbering of carbon atoms in the hydrocarbon chain begin from the side which nearer to the branch. And the nomenclature in this case begin with the number of carbon atoms at which the chain arise, or the number, then the name of the branch, okay, preceding by the number of carbon that attached or linked with the side group, then ending with the name of alkane. Okay? Let's take example to illustrate or check your understanding. Okay? In this page, we have two examples, okay? So, in this compound in front of you, this is a side branch or alkyl group. So, the numbering of carbon starts from here. 1, 2. So, first we write the number of carbon that attached with the side group. Then, we put the name of the side branch. The side branch in this case, methyl. So, we write methyl. and begin to complete the numbering of carbon. 1, 2, 3, 4, 5. The 5 alkane known as, from the alkane group, known as pentane. For the compound name according to IUPAC system, to methyl pentane. If the side group is repeated in the hydrocarbon, we use prefix di or tri or tetra, where di represent two side group, the same side group, tri 3, and tetra represent or refer to 4 same methyl, same side branch. Take an example. This is a longest continuous carbon chain, and we start from the carbon near to the branch. 1, 2. So write 2, then 3, because carbon 2 and carbon 3 attached with the 2 side group, and we have the same side group, two same side groups. So we express them by dimethyl, and we put the name of alkane at the end of the name, pentane. So because this chain contains 5 carbon atoms, so the compound 2,3-dimethyl pentane. Also, this example, we have 2 methyl group attached to the carbon number 3, so the name 3,3-dimethyl pentane. If the branch or the side group, a group of halogen, chlorine, bromine, or nitrous, the name of this group ended with letter O, as 2-bromo-propane, or 2-dichlorobutane. If the side group containing side group are different, alkyl group and halogen, so we will start by the side group according to their alphabetical Latin names, after the numbering from the end that given the branch, the least possible summation. So we have bromine side group and methyl side group. So we'll start from bromine, then numbering the carbon. 1, 2, 2 bromo, 3 methyl, and the root chain name butane. Start from bromo according to alphabetic, and we should to put the number of carbon which attached to the side group. Also, we will start from chloro, so the numbering starts from here. This carbon is the first. So the second carbon linked with the chlorine, so the name will be 2-chloro, 4, because carbon number 4 attached by or linked by 2-methyl group. So the name 4,4-dimethyl hexane, because the longest chain contains 6 carbon atoms, and so on. The second group called alkenes. Alkenes from unsaturated open chain aliphatic hydrocarbon, that contain at least one double bond in the carbon chain. The double bond consists of 2 bonds. One of them is strong sigma bond, and the other weak pi bond, which is easily broken during chemical reaction. This explains the activity of alkenes. The name of alkenes derivative from the name of the corresponding alkane by changing the suffix ane by ene, because alkenes is considered from alkanes but by removing 2 hydrogen atoms. So it's a chemical formula CnH2n. Okay, let's start. We know that the compound that contains 3 carbon atoms known as in alkane group alpropane. Okay, but this compound contains 1 double bond, so it's related to alkenes. So its name changed from propane into propene. Okay, by changing the end of ane or suffix ane and replaced by ene. Okay, the numbering of carbon chain in case of alkenes start from the nearest carbon to the double bond, regardless the position of other group. Okay, so we will start the numbering of carbon according to double bond. Give example, this compound in front of you. Okay, we will start the numbering of carbon from the carbon nearest to the double bond. 1, 2, okay, 3, 4, 5. Then the position of the side branch linked to the carbon number 3. The name becomes 3-methyl, okay, 1 refers to the position of the double bond, pentene, okay. Another example, we will start the numbering of carbon from the position of the double bond, okay, 1, 2, 3, 4, okay. So we start for chloro, okay, because carbon number 4 linked with the chlorine, and then we mention the number of the carbon that has double bond, okay, number 1, then the name of the alkene, butene, okay. The third group called alkynes. Also, alkynes are unsaturated open-chain hydrocarbon, aliphatic hydrocarbon that contain at least triple bond in carbon chain. Also, alkynes form homogeneous series, okay? So, it's chemical formula CnH2n -2 or -2, where by removing 2 hydrogen atoms from alkene, we obtain alkyne. Okay, and also alkane, when the alkane group losing 4 hydrogen atom, it changes into alkyne. Okay, so the name of alkyne also coming from the corresponding alkene or corresponding alkane by removing ane, suffix ane by yne. Okay, the triple bond consists of 3 bonds. Strong, one of them is strong sigma bond, while other 2 bonds are weak pi bond. Therefore, alkynes are very active compound, okay? Because due to the breaking down to 2 weak pi bonds during chemical reaction. The first compound in alkynes group called ethine, okay? It's a symbol C2H2 and its common name is acetylene, okay? Where acetylene used in cutting, acetylene gas used in cutting and welding metals. Because acetylene very active, due to it related to alkynes, it can react with the oxygen, okay? And form flame known as oxyacetylene flame used in cutting and welding metal because its temperature reached to above 3,500 degrees Celsius, okay? Nomenclature of alkynes, okay, by the same way, we start the numbering of carbon from the carbon that has triple bond, okay? 1, 2, 3. 3 bromo, okay? 1 because carbon number 1 contains triple bond butene. Example number 2, okay? We will start from the carbon that nearest to the triple bond. 1, 2, 3, 4, 5. 5 chloro, okay, to the position of the triple bond pentyne, okay. Also, we have cycloalkanes. What's meant by cycloalkanes? A hydrocarbon that contain 3 or more carbon atoms but found in cyclic structure, okay. Its chemical formula CnH2n, okay, which is the same molecular formula of aliphatic alkenes, open chain aliphatic alkenes, okay, but differ from alkenes the absence of double bond, okay. The name of cycloalkanes coming from the corresponding alkane that preceding by cyclo, word cyclo, okay. So we have, this is contain 3 carbon, the compound that contains 3 carbon in alkane group called the propane, so the compound become its name cyclopropane, cyclobutane, cyclopentane, okay. Also we have another example, cyclohexane, okay. Thank you. Grade 11.